Hey everybody. In class these last couple days we've been talking about writing expressions and equations and inequalities. Tonight we're going to talk about writing a special kind of equation called a function. And a function consists of three things. A function needs to have a domain, that's a set of input values. It needs to have a range, a set of output values. And it needs to pair each input with exactly one output. So for instance, if 2 is an input that gives us 5 as an output, 2 can only give us 5 as the output. And you'll see more of what I mean in a second. Let's take a look at an example here. Now if you're doing this in notes, you don't need to copy down the whole problem, but I suggest you copy down the table so that when you look back at your notes, you'll know what we were talking about. So here we have a group of inputs. We're talking about gallons of gas here, and the input of $10 gives us $19.99, $12, $23.99, $13, $25.99, and $17, $33.98. Now notice how we have a group of inputs, that's the domain. We have a group of outputs, that's the range, and notice how each input gives us exactly one output. Right? We don't have any input giving us two different outputs, because then that wouldn't be a function. So if we want to write the domain, here's how we do that. We can say domain. Now, to write a set of numbers, we use something called set notation. We use these curly brackets, and then we just list the group of numbers that we want to include in the set. Okay, so that's our domain. It has a set of 4 numbers, 10, 12, 13, 17, because the domain represents the input. And then we have our range. The range is the set of possible output values. So we'll list those also in the brackets to show that it's a set of numbers. And I'm going to have to do 2 lines here because I wrote too big. 3398, and then I'll close my brackets, closing the set, and once again we have 1, 2, 3, 4 different numbers in this set here. Here's another table. You're going to want to draw this one out too. Now here what we're going to show is a different way to display a function other than a table. So this is called a mapping diagram. And what the mapping diagram does is it shows how the inputs go to the outputs. Mapping diagram. So in our mapping diagram, we draw one box for our inputs, right? This is where our domain elements go. And then we draw another box for the outputs. And now we can list our inputs and outputs in the boxes. So our inputs, we have 0, 1, 2, 4. That's our domain. And the outputs, we have 5. Now it says 2 and 2. I have 2 2's, but we just have to write 1, 2, and 1. We're only listing the elements in the range, so I don't need to write both 2's, right? Because the range consists of 5, 2, and 1. And now we draw arrows from each input to the output. So 0 goes to 5 according to the table. 1 goes to 2. 2 also goes to 2. And 4 goes to 1. Now, a lot of people get confused when we see mapping diagrams, when we see 2 different inputs go to the same output, right? We have 1 going to 2, and we also have 2 going to 2. This is still a function because 1 always goes to 2. The input always goes to the same output. This 2 also always goes to 2. That's fine as long as this 2 in the input always goes to 2 in the output. An input can only have one output, but an output can sometimes have more than one input. So here's an example of what I was talking about right here in example A here, right? If I want to know whether this is a function, I need to see that each input goes to only one output. Now, 10 goes to 5. 5 always goes to 4. But here I have 0, and 0 goes to both 2 and 0 goes to 3. Functions have to be consistent because I can't predict what 0 is going to do. It might go to 2, it might go to 3. This is not a function. Not a function. Okay? Now, in example B here, 0 goes to 0, 1 goes to 2, 4 goes to 8, and 6 goes to 12. And there's no inconsistencies here. Each number, each input, always gives me the same output. So this is a function. Functions aren't always represented by tables or mapping diagrams, because in a table or mapping diagram we can only fit so many numbers in. And sometimes we want to include a lot of different inputs and outputs in our function. So one thing we use to do that is called a function rule. A function rule is an equation that relates one variable to another. So for instance, if I have y equals 2x plus 3, this is a function rule that relates the variable x to the variable y. When we're working with functions, we have special names for these variables. The independent variable represents the input in the situation, right? Independent input. That's an easy way to remember it. And the input is usually represented by x. So x is usually the independent variable, and the dependent variable represents the output, which is usually y. And that's because y, the value of y, is dependent upon whatever x is. We can put in whatever value we want for x, and then that'll give us a value of y. And we can use this rule to make a table. If I wanted a table of x and y values, and we'll just do 4 here. 1, 2, 3, 4 going across. And for my input values, I'm going to choose 1, 3, 6, and 10. Okay, I'm going to choose those as my input values, and I'm going to calculate my output values, my dependent variable values. So to find y when x is 1, I can do 2 times 1, which is 2 plus 3 is 5. If x equals 3, 2 times 3 is 6, plus 3 is 9. So my y value is 9. Y equals 9. Same thing for 6. 2 times 6 is 12, plus 3, that's 15. And same thing with 10. 2 times 10 is 20. 20 plus 3 is 23. So I know that was a lot tonight, but the more we're able to get done, the faster we're going to be able to move, and the more we're all going to learn. I'll see you guys tomorrow.